Today we'll be going over Newton's laws of motion. So the essential questions we're looking at are what are Newton's laws of motion and how do the laws of motion apply to sports, amusement park rides, Earth's tectonic forces, and rocket launches. So force is a push or a pull on an object, and it causes a change in the motion of the object. An object's mass multiplied by acceleration is the force. So you can see here, and you can see there's mass times acceleration is the force. And force is always measured in newtons. A balanced force is when there's two forces acting in opposite directions on an object and they're equal in size. As you see here, there's 10 newtons down, 10 newtons up, 12 newtons to the left, 12 newtons to the right. And because those forces are balanced, that object will stay still or it will continue moving at the same speed and in the same direction. This particular one will stay still because the forces acting on it are equal and in opposite directions. An unbalanced force causes a change of motion in an object, and it causes acceleration. So imagine pushing this young girl on a swing. As you push her, you're putting an unbalanced force on her, and the harder you push her, the faster she goes. So pushing causes acceleration. The net force is a combination of all forces on an object. We have 14 newtons going to the left and 10 newtons going to the right. So we would take 14 minus 10, and the net force would be 4 newtons. So it asks how you can make the forces on the right balanced. You would have to add 10 newtons to the right to make that balanced. Friction is a force that causes a moving object to slow down when it touches another object or one object rubbing against another. So here we have a boy pulling this dog and this girl, and instead of wheels, it has skis. And all that friction is caused because there's so much of the ski that is rubbing against the ground. And remember, friction is a force, and force is always measured in a particular unit. And if you don't remember, go back and look on one of the slides before. Speed is how we measure how quickly something is moving or something is being done. So if you're on a motorcycle and you're going 55 miles an hour, if you can sweep a floor in 5 minutes, that's speed. But speed is very different from velocity because velocity also includes the direction something is going. So velocity changes when the direction changes. Acceleration is the rate that something is speeding up or changing its direction or slowing down. For instance, as you're going up on a roller coaster, so it takes a car up to the top of the hill and then it starts going downhill. At first you're speeding up, but as you get down to the bottom of the hill, you start to slow down. That is still all acceleration. And there's a change in acceleration when you turn a corner because then you've changed direction. Okay, applied force. So that's when there's a force that's applied to an object by a person or another object. For instance, if you're pushing a box up a ramp, a bulldozer moving dirt, and there are some examples on a roller coaster. When you think about it, the car pulling you up, gravity pulling the car down. So you're going to put 3 times acceleration happens on the roller coaster. Here you're going to drag away the term to see if you're correct when you're looking at these definitions. So push or pull, whether that's a force or a net force, you will pull the word you think that's correct away. It will let you know beneath. So here you're going to design a safety restraint for a motorcycle, a four-wheeler, or go-kart. You can draw it and put a picture in, or you can just describe here how you will design it. Make sure you explain how your device protects against the driver against the collision forces. So you're going to look at the terms on the left. You're going to put an arrow in or a line to the correct term. So Newton's laws are named after Sir Isaac Newton. He was an English physicist and a mathematician in the 1600s. He actually lived through a pandemic as well. That's when he came up with a lot of his theories. He also invented calculus. He was one of the most influential scientists. He also came up with the 3 basic laws of motion. People say he discovered gravity. He didn't exactly discover gravity. It was there all along. But he was able to figure out the laws of motion. So inertia is that an object at rest tends to stay at rest unless it's acted on by an unbalanced force. For instance, if you're standing on a skateboard and not moving, you will not move unless a force acts on you. The rest of his law says an object in motion tends to stay in motion at the same speed and direction unless acted on by an unbalanced force. Now, this example is a very poor example because a satellite orbiting Earth actually has the force of gravity acting on it. A better example would be a space probe going through the solar system, and it will continue at the same speed and direction until it gets pulled into the gravity of a star or another planet. So you're going to complete the top row here. You're going to tell me something about Isaac Newton, and you're going to explain Newton's first law. So when we're in vehicles, we wear seat belts, and roller coasters use bars and seat belts often. Why is that important? Thinking about Newton's first law, how does that keep you safe? Explain how those keep you safe. Make sure you identify forces and velocity on this. All right, so Newton's first law, you're going to summarize what you know. You're going to click and drag the correct definition for inertia and friction to their correct location. So one of these will be here, one of these will be here, and then you're going to give 3 examples that demonstrate the first law of Newton's laws. Newton's second law says the acceleration is dependent on force and mass. When you think about, say, a football player running toward a 4-year-old, who's going to fly up into the air when the football player hits the child? It will be the child, because the football player would have a lot more mass. Acceleration is produced when force acts on a mass. So the greater the mass being accelerated, the greater amount of force needed to accelerate the object. If you have someone that weighs 50 pounds standing on a skateboard, they're easier to push than someone that weighs 300 pounds on a skateboard. You're now going to fill out here Newton's second law. And now you're going to explain what does F equals m times a mean. If you don't remember, go back into the earlier slides. What would be the formula if you want to solve for acceleration? So you're going to have to take this formula and now solve for a. And then you are going to solve these 3 equations. Newton's third law is for every action, there's equal and opposite reaction. For example, a rocket taking off. So what happens is there's a reaction that the rocket pushes against the ground, but the ground also pushes against the force from the rocket. And so the gas being expelled from the rocket pushes against the ground pushes back, and the rocket goes up. Newton's third law also is explained with earthquakes. We have unbalanced forces, so we will have tectonic plates move past each other or beneath and above each other, and those unbalanced forces create earthquakes, volcanoes, and other geological features. Mountains is another geological feature that is created by unbalanced forces. Here you're going to explain Newton's third law. Think about it, you're thinking here specifically about mass and acceleration, and answer questions A and B. Now you're going to explain your own words how a rocket's able to lift off, what would happen if you let an untied balloon go away, why it would act this way, and what would happen if you're standing on a skateboard and then push the wall. So using the Newton's third law, make sure you say, what would Newton say in those three bubbles? Here you're going to identify whether or not the statement is referring to Newton's first law, second law, third law. You will then drag the box for the correct law over and put it in the box over here. Describe Newton's three laws of motion. Make sure you describe all three of them. Don't just give a little summary of Newton, but the first law is this, the second law is this, the third law is this. And give a really good explanation on how they apply, Newton's laws applies to sports activities, amusement park rides, Earth tectonic activities, and rocket launches. And then if you have any other questions. If you have any questions on this, please let me know. Have a great day.